Okay, let's get started. You're stuck with me once again. John's out of town. He'll be back next week.
Real quick, October, since the day before homecoming, we're having an alumni open house, so we might have some alumni in the building. Unfortunately, Professor Martin and his entire research group, and just about anybody else who would normally run Weather Watch, is not going to be here. They're at a cyclone workshop. So, any of the rest of you who ever had thoughts or dreams of maybe trying to do some of this, which all of you are probably capable of at least getting up there and saying, hey, look, this was cool this week, that would be wonderful. Everyone's shaking their heads no, but
you can also skew it to what interests you a little bit.
Yeah,
like we always talk about synoptic things. You don't have to do that.
So start thinking about it. Keep it in mind. I will probably be recruiting people to try to help with that.
Yeah.
So, anyways, that's all.
Okay. So, could we start with the surface map, please? The surface obs, anyway. A lot going on, just not for us. So, start out. Here's our current surface map. We are sitting pretty at a cool 63. It's finally feeling like fall, thank God. But yeah, we've had pretty relatively boring weather, except for last night when we had, I believe, a little bit of rainfall, right? I know, yeah, a little bit. Some people didn't expect it, others did expect it. It kind of almost came out of nowhere. However, that band is currently sitting south of here, through Illinois, all the way up to Michigan. Anywhere you see this like, full cloud coverage, it's at least the cloud band. I think it is still precipitating a little bit, but we'll see that here in a second. When we look at radar. Also, the entire East Coast has some form of cloud cover, a little bit of like rain, it looks like, rain signatures. They really don't need that right now, as I'll also show here in a second, because they're, especially North Carolina and southward, still recovering from the torrential downpours that came with Helene. So yeah, not a good scenario for them at the moment. And then, go over here. There's also, per usual, the Pacific Northwest is getting hit by a system dumping rain on them. Plenty of cloud cover, especially if you're in northern Washington. But I feel like that's pretty usual for them this time of year, right? Yes. So, nothing new for them. Can we go to satellite, please? The GOES IR loop east in infrared, yeah. So yeah, here's a look at our satellite as of now. The infrared channel. See, here's that band of clouds that is beginning to dissipate. The further it gets away from us, this is what dumped the rain on us, or late this morning, or late last night. Yeah, it's moving out of here. It was cloudy this morning when we had the remnants. I don't know if anyone else saw, but on my walk to the building, it was pretty cloudy. But now all of that appears to be gone, and we're back to the blue skies we've seen for like the whole week.
It's a pretty cool shadow from that angle this morning on the visible satellite. Like just as the sun was coming up, you could super cool shadow.
That's cool. Lots of convection in the Gulf. I know, I haven't looked too recently, but I know the Hurricane Centers had their eyes on a couple of these just to see if anything's going to develop, which they really, really do not need, given that they're still recovering from Helene. So hopefully that just remains as the standard Gulf of Mexico convection that we see so frequently. And then here's a large swath of clouds we can see associated with what is moving in on the west coast up near Washington. Other than that, if you live in the central U.S., you've got nothing going on, pretty blue skies. Very boring. I think it's been that way for most of the week. Not a lot going on. Could we go to radar, please? Yeah, so here's the radar. Almost lines up with all the cloud cover that we saw on the satellite. You see, this is the band of precip that we got a little taste of last night. It's now really starting to dissipate, mainly kind of just raining in central Illinois at this point, but that's even about to die out. You can see the convection that we saw in the Gulf associated with some thunderstorms, it looks like, on the Gulf Coast, mainly in like Florida, Louisiana. Some more rain for them, even though they really don't need it. And then a little bit of rain associated up here in the Pacific Northwest. But yeah, other than that, nothing if you live in the central US. We've had a pretty, if you're living middle of nowhere, middle of the US, not a lot going on. And as you might expect from all of this, nothing happening. Could we go to the drought monitor? Sorry, I should have sent you that beforehand.
Oh yeah, 2 over.
Oh,
to the left.
yeah, it's right here.
Yeah.
Oh, could you refresh it? Yeah, there we go. So yeah, as we're seeing high temperatures in the central US, the radar, clouds, they don't even have any clouds, much less any rain. There is, slight drought over a vast majority of the US. Like everywhere that's yellow, I think if you scroll down a little bit, it tells you the specific. Yeah, they're abnormally dry, and then the like tan color is moderate drought. So if we scroll back up a little, yeah, most of the US is covered in that. It's just not raining. No one's really getting any rain unless you live in the southeast. Especially in places like Ohio and West Virginia, they're in a really strong drought when compared to, just a few miles south where they're in severe flooding. On that note,
The rain we got last night was not a drought buster either.
Yeah,
it was
no,
just some
it was
drops.
this
I think it said it was a
sprinkle.
trace.
we're still in like abnormally dry, maybe getting on the borderline of the tan drought, but yeah, very dry everywhere. But on that note, could we go to weather.gov? And then scroll down, please. And go to observed precipitation. And then zoom in a little bit on the Carolinas. And then if you click, okay, so click this to get rid of a bunch of the boxes, because they're not what we need right now. And then you enable precipitation estimate. This might take a second. Maybe, because there's a lot going on. Oh, could you hit down, please? Sorry. And then month. So this is the monthly precipitation estimate for the month of September. So the month we just finished and when Helene dumped most of its rain. So you see in the borders of North Carolina, a little bit in South Carolina, where we're seeing, still lots of people trapped from flooding, lots and lots of damage from flooding. They're still trying to evacuate and recover, even though Helene was a week ago at this point. They're still struggling. This white color, could you scroll down on this bar a little bit? So the whites, greater than or equal to 20 inches of rain. So they got, dumped on, absolutely poured on. And this is in, all of the mountainous valley regions of Appalachia. So all of that's getting funneled, roads are destroyed, people are trapped. It's really, really sad. So, really hoping everything that's still developing in the Gulf and elsewhere, they really don't need any more of that. And they need as little rain as possible.
Does anybody remember James Anheuser? He was a graduate student here, got his PhD. So he and his wife live in Asheville. They were actually over in Scotland when all this happened. They had a friend that was watching their cat, and they were like freaking out on what was going on. Turns out their house is fine. The cat is fine. They were able to get back. They flew into Atlanta and drove up and picked up a bunch of water on the way. His office is closed until at least the 14th. Their power came back on last night while I was texting him, and he said water is out and probably will be for months, or weeks, if not months. Because, a lot of the big flooding that happened took out a lot of the roads, which took out a lot of the water mains, which means rebuild water mains, and that's gonna take a long time. And like you say, all people that are, up in the hills that have like one road to get to their
Yeah.
place, and it's gone. They're taking in medical supplies on mules.
They're trying to do helicopters as well.
Yeah, it's really, really.
I saw a
bad.
video
It's
of
taken
someone
a long
trapped,
time.
they flagged down a helicopter, they brought a mirror out from their house and then just reflected it to get any form of help, caught a passing helicopter.
It's gonna be a long time before it's back to normal down there. I don't know if NCEI is back online. The National Data Archive, NCEI, is in Asheville. Are they back on?
No, I looked this morning.
So I think they have power. They're on backup power, but they lost the fiber cable for their internet, so that's probably lower priority than getting water line.
Yeah.
Crazy. They got like 4 or more months worth of rain in 3 days. And a lot of it too, well, I was reading this morning, a lot of some of the really catastrophic flooding, the wind took down these really old trees, and then those would sort of hold up water behind them until it hit like a break point, and then it would just all come down at once. And people had, you know, the rate the water came up, at the time they realized they had to leave was too late, and a lot of people died because of that.
Quite literally worst case scenario.
Yeah, it was terrible.
But with that, we'll switch over to the super peaks to see what else has been going on. If you could do 250 GFS loop reviews. And then, yeah, we can honestly just move on. There's, you know, like I said, other than Helene and all the impacts of that, not too terribly much going on. The jet stream, seems like we have one distinct jet structure that's dominated this past week. So this is from last Friday all the way till today. And it has stayed, you know, mainly north of here. There's some ridges. I believe we end this time period sitting in a trough in the jet. However, it's, you know, mainly stayed on this US-Canada border, so all mostly north of us. Not a lot of impacts from that, which kind of leads, as we look at the lower levels, to the lack of weather that's seen everywhere in the US. Okay, can we go to 500, please? Okay. So at 500, this starts out with a low pressure system right here. That is Helene. So last Friday, Helene was pouring all this rain on everybody. It gradually moves out. And then you can see kind of the same story. Troughs, ridges, but ultimately not a lot going on. There are some monster winds up at this level, but once again, it all stays on the border of US and Canada. So if you live in southwestern US, you're not getting anything from this pattern up here. You're just kind of stuck in this overwhelming high that will be more apparent as we go to lower levels. So ultimately for the US, everybody had Helene over here, a big high pressure system over here, jet up there, not a lot going on.
A lot of heat in the southwest. I
A
think,
lot
too,
of
right?
heat in Southwest.
California,
Patrick's going to
Arizona.
talk about that, I
Okay.
believe. And then I'll switch to 850 because that's not all I have. Isn't that all I have? Yeah. So you can really see Helene at the start of this time period, right here. It eventually moves and dissipates as we go throughout the last week. As for us, you can see this low pressure system that, you know, moves through. It brought with it a front on Tuesday. That's why, you know, we're finally free from the highs in the 80s. We're seeing, you know, highs in mainly low 70s, upper 60s. I mean, highs, yeah. And then we also have lows in the 40s. So it's starting to feel more like fall. The leaves are really changing. I don't know if any of you all have seen that, but it's finally fall temperatures getting a break from the constant, you know, 80s, always clear skies that we've seen for the past few weeks. And then, yeah, so this is up until like right now. There's a lot sort of brewing on the West Coast. I won't talk about that because that impacts the future forecast. However, yeah, with that, that's about all I have. Not too terribly much going on other than this high that has been set over, you know, almost the entire western portion of the U.S. for no weather but heat. So does anybody have any questions before we switch? Okay.
Perfect.
Thank you, Libby. Could we start with weather.gov, go back to that, please? So I'm going to talk about a different extreme. I feel like a broken record, but Phoenix is still hot. And hot is an understatement, and I'll prove that to you here. So if we could click on just the general Phoenix area. They've been under excessive heat warnings for most of the summer, 4 or 5 months. Let's click on the record temperature forecast. This is a look at going from Friday to Tuesday. The forecast is the top number, outlined in black. The record is in red, okay? These are all-time record highs being broken for 5 days in a row. So this is impressive to begin with. This is 3 different cities in the Phoenix area, all breaking all-time record highs. This is more impressive because this has been going on for 10 days in a row now. They have 5 days, you know, not even just breaking records by 1 degree. These are 5 to, where's the highest? It looks like 5 degrees. So they're shattering all-time records. 15 days in a row of all-time record highs. If that happened here, it would be, you know, mayhem. We would be able to sense it. This has been happening for the whole summer, okay? So this is, you know, bad enough. You were to look at this and say, wow, this is pretty extreme. However, like I've been saying, this has been going on since May. And we'll look more into that. It's not just Phoenix, it's most of the desert Southwest, but this is, you know, the largest city that's being impacted by these record temperatures. And it doesn't look like there's any end in sight. You can see it goes all the way to Tuesday. We're still forecasting record highs. So it feels like fall here. It does not. In Phoenix, it never can because, you know, it's so hot. But these are summertime type temperatures that they're experiencing, and it's October. And if we could click on the monsoon recap too, I'll also show this. So you can see for a period from June 15th to September 30th, they experienced the 6th driest period. So it's been hot and dry, and shattering the average temperature for this period by, you know, almost 2 degrees Fahrenheit. And you can see, no comment, but 2024, 2023, 2020, 2011, 2015, 2007, these are all recent years. And so if this trend continues, you could imagine that we would keep seeing records broken. Millions of people living in places that the temperature is like 115 every day. I can't even imagine that. You can't even live outside in those temperatures. And so this is something very serious. Different from the flooding, this is the complete opposite, but it's still pretty impactful, as we can see. And could we go to the UW-AOS? I'm not sure how to pronounce this. There's one website, which if you're curious, I can send you the link, but it does climate records for individual stations across the United States. This is a website you could waste a lot of time on, and I recommend doing it because it's pretty interesting. But let's go to the single station. And if we could go to consecutive days, and we'll do max temp, if you could type 100, please. And then if we go to select station, and we'll do ID, and we can do KPHX for Phoenix. So if you haven't been convinced that this has been a weird year for Phoenix, and we can click go. And if you could zoom in maybe to make this a little bigger. Let's just see how anomalous this is, okay? So going up, before this year, the previous number of consecutive days above or equal to 100 was 76. They managed 113 days in a row, greater than or equal to 100 degrees. You'll notice this ended September 16th, and it's October 4th. They're continuing to get record days over 100 degrees, okay? So the maximum number of 100-degree days is 145, not consecutively, just total. You can imagine if we were to add 20 or 30 days to this number, which is the trend, we're getting close to the number of days all time greater than 100 in Phoenix. That record, by the way, was set in 2020. So you can imagine you survived 2020, you're like, great. For obvious reasons, 2020 was a terrible year. It was super hot in Phoenix. 4 years later, let's make it hotter. Sounds terrible, absolutely terrible. And you'll notice the trend is that it will continue to be terrible. Could we also do, on the single station, if we do extremes, and this is perfect, we'll go to click days, and we'll make it years, and then 1 year. So what I'm showing is the average max temperature for a year, and we can just click go. If you're still not convinced, this is the maximum 1 year mean temperature, okay? Their maximum mean temperature is 93 degrees, which is pretty close to the record, set in way back when. But we still have 90 days to go. So if you remember back where I was showing the temperature records, they're expected to go highs, near 110. So you can imagine this number would go up, the average max mean temperature. And you should see that this value will approach the all-time record. So many ways to measure these records, but you can see there's multiple ways they're continuing to break heat records and will continue to do so. It does not look like for the next week that this will end. So very concerning. Again, 2012, 2014, 2023, 2017, 2020, 2024. These are all very recent years that they have broken these records, and it looks like this year might be hotter than the previous records. So this is concerning, on top of the flooding. Okay, if we could go to weather.gov, sorry to bum you out, but it's interesting from a weather standpoint that this is happening, but it's very sad that it's happening because it's impacting a lot of people. And let's just look at the watches and warnings now here. You can notice the western portion of the United States. It looks like there's a lot going on, and there is. These are all red flag warnings, the brighter pink colors, and wind warnings in Montana and North Dakota. So you can imagine there's a system probably going through producing a lot of high winds, which we'll see. Here's all the heat. The color map is terrible, but the darker pinks, these are all excessive heat warnings and advisories. Some air quality alerts in the central, in Texas and then Oklahoma. As we see, there's not a lot of systems going through, so the air is just sitting and producing a lot of pollution-induced air alerts. And then aside from that, some flooding. We will probably continue to see this where Helene tracked flood warnings. If you can make out the little green specks here, those are all along rivers on the eastern portion of the United States. So I will be touching on the system that's going to bring some interesting weather, especially for the weather-challenged city of Missoula, and will impact us going forward too. But that's what I wanted to touch on here. If we could stay on this website and scroll down to the QPF, under forecast, current outlook maps. We'll look at the quantitative precipitation forecast, so liquid precip, the forecast across the United States. This is today into tomorrow morning. You can see here's the blip from the rain that Libby showed, went through our area, western portion, far western, northwest portion of the United States under precipitation. Gulf, very active. You can see we saw convection. All speckled, so you wouldn't expect this to be any organized precipitation. But then, much of the country where we saw the drought, Phoenix, hot, dry, no precip. Let's go to day 1 through 2. This will now add days. So this is a 48-hour forecast. You can see largely the same picture. Something appeared over, no, you're fine. Something appeared over, central Canada, getting into Michigan and Wisconsin, which is the system I'll talk about. If we keep going, day 1 through 3, not a lot. Something has continued to move across the northern portion of the United States, now getting into the northeast, day 1 through 5. Same sort of story, day 1 through 7, largely dry for much of the portion of the United States, aside from Florida, which I didn't really point out, but these are places that got hit by Helene. It wasn't as extreme as North Carolina. But you can see this is still 5 to 10 inches of rain over 7 days, which they know how to deal with more so down there because it happens a lot, but this is still a significant amount of rain right after a hurricane. So that's something to watch as well, aside from most of the country being largely dry. And especially over us, no precip forecast.
Yeah, the other difference between the heavy precip in Florida versus North Carolina and the Appalachians is terrain.
That's right.
It's basically flat and the soil is sand, so it runs off or drains in really quick compared to rushing down a valley with a creek that's usually jump across and all of a sudden you got 10 feet of water running through it.
Exactly right. Yep. And it is, even though it's a lot of precip, it's sustained precip. So if you get a lot of precip over a long period, you're going to have less impacts than 4 months of precip in 2 days. It's much different. So yeah, that's a great point. Could we go to our weather watch links, please? Like, I'll highlight the system that's going to impact Missoula and then into our region as well going forward here. Could we go to the Python? And then we'll start at 500. We could just do the loop. Perfect. And could we go to tonight at 0Z? So this is a look at tonight at 0Z, largely the same picture, but I want to highlight this trough is going to be the feature of interest here. If we step back just 2 clicks, I believe, you can see this trough originated over the western portion of North America, over the Pacific. Is beginning to interact with the Rocky Mountains here. So we'll watch an interesting development from that. The only other trough of interest would be the system bringing us the cold air that we've noticed, but it's on its way out, as we'll show here. Other than that, general ridginess over much of the United States, which leads to calm, dry, clear conditions. And this time of year, sun angle is still relatively high, so it's still hot, especially over Phoenix, like I've been pointing out. And let's go, if we could go 2 clicks forward then to tonight. We'll see the trough begin to move over the mountains. If we go 2 more clicks now, explosion of vorticity. Now we're into the purples. Let's go 2 more clicks. Actually, 1 back, I'm sorry. We begin to get into this white color shading. So the white shading is about 6 or 7 times the Coriolis force, and you'll see it, all it did was move across the mountains. There is no real reorientation of this trough. It remains largely the same curvature, largely the same shear change as it moved over the mountains. But I want you to notice, if we go back to the start, like 6 hours into the forecast, the latitude changed. So right now our trough is situated largely north of the United States. As it moves over the mountains here, we'll see the trough move to lower latitudes. That's a function of the column height is changing as it moves over the mountains, and we'll see that with the low pressure system as well. You decrease your height as you go over the mountains, so you have to conserve shallow water PV. You're going to decrease your vorticity, begin to move equatorward. Okay, so it begins to move equatorward. Once you get on the other side of the mountains, you increase your height of your column. You begin to increase your vorticity and move poleward. Let's go a couple clicks forward. That's exactly what's happening right here. It moves over the mountains. We lose a lot of that vorticity. It weakens a little bit. Then it gets on the other side of the mountains, gets pretty strong. Now we have a nice development of this trough. Vorticity increases, latitude begins to increase, and it moves northward. It's exactly what's happening here. You could imagine, which I'll show here, pretty significant cyclone developing right downstream of this. Just from this look, we can see there's a nice, very neutrally tilted trough. Downstream ridge, not too apparent, but it's there. Lots of vorticity concentrated right along the apex of this trough. So right downstream, you would expect a lot of divergence aloft, convergence below. Your cyclone is going to be situated very close to where this trough is located at 500. And let's just keep going here and watch the progression of this trough. So we'll see it looks impressive at times. It also, the vorticity begins to become spread out and sort of unconcentrated as it once was. But this begins to move over our region. This now looks like almost exactly what is happening right now, where we have a trough situated over us. So you can imagine this will usher in some cold air as it moves over our region. And the cyclone associated with it is going to stay largely over Canada. So we might see some precipitation, but most of it is going to be southern Canada as this trough moves. And then if we just keep going, let's go to just to Monday at 0Z. So we'll get you through the weekend here. It's the end of the weekend. Big ridge, over much of the country. Phoenix the entire time has stayed under this ridge. This has been repeated months of just sitting under a ridge. And let's just go to the end of the forecast, and I'll just highlight Phoenix here. We just let it play. is a ridge the entire time. Maybe a system at the very end, but this ends
I think 8 days or 10 days.
8 days, yeah,
8
so
days.
next weekend is when maybe there's a chance that Phoenix is not 100 degrees plus. Then again, this could change very dramatically over the course. And you'll see it's a short-lived system. Could we pause it at the very end, please? So you'll see, here's a maybe trough ushering clouds would be good. Maybe some precipitation. Right downstream of it, here's another ridge. So, I don't know. It's going to be something to watch, how hot it stays over that region. And, you know, as a consequence, much of the country downstream of it also stays under a ridge as well. Can we go to the loop at the surface?
Maybe it's east and the Pacific.
Yeah. Who knows what this is? Look at that. You can trace the vorticity. It wraps around itself 1, 2, 3 times into the center of that. And then there's a equally large one at the end over the Atlantic. Right here. So, interesting weather, not for us. Portions of Canada, definitely. And it doesn't look like the wave train is going to move south anytime soon. It's largely remaining over Canada, so we are not going to get any of these systems, it seems like. Maybe even a little hurricane develops after this one. At the very end of this GFS run, there it is. So, something to watch, for sure. If we go to the surface, we'll do the same sort of analysis with the loop here. So I showed that trough development. We could stop it. Perfect. Start 6 hours, yep. So you'll see general area of precipitation downstream of where that trough was. Not a clear surface cyclone. Maybe there is one beginning to develop in the lee of the mountains. Aside from that just column conservation of shallow water PV, you're also getting column stretching, which stretches your column just like a dancer. You spin up vorticity near the surface. We'll watch this development become significant. Now we're down to the 980s. A lot of the precipitation, though, you'll notice, forecast, not a lot. So we are generating a system that's well away from any moisture source. And it's buried, or there's a big barrier in the mountains. So a lot of the precipitation is going to rain out. You go across the mountains, you dry out your column, you spin up vorticity, but if you don't have any flow from the Gulf, which very weak synoptic flow, you're not going to have any real precipitation with this system, especially ahead of it, which is noted by the model here. What is significant, especially at this time, if you trace the white lines, which are the isobars, compared to the thickness lines, this is going to give you a sense of temperature advection. And so out ahead of this system, really strong baroconicity, as noted by the tight gradient in the thickness, really strong winds. These, if you assume geostrophic winds around this cyclone, you're going to have really strong warm advection ahead of it, and really strong cold advection behind it. This is 6Z tomorrow morning, so this is the end of the Missoula forecast, and you can see a cold front moved through Missoula and a little precipitation. Very nice thermal structure, not very nice precipitation structure with this system. If we step forward, just go a couple clicks, you can see now we get some interesting precipitation. This system continues to develop. Now it's 982. Out ahead of it, really strong warm advection, especially over our region. This is tomorrow. I know I'm from Nebraska, so I follow Nebraska football. 92 degrees tomorrow for a high. October. This always happens where you're like, oh, it's fall, great, let's go to a football game. You sit in the sun, it's 92 degrees, it's terrible. Even here, though, it's supposed to get up close to 80, which is unnatural for this part of the country as well. And you can see it's a function of this cyclone, really strong warm advection. But just right behind it, you can pick out a nice cold front, pressure trough along it. So you might expect quick warm-up, quick cool down. And we'll see that if we keep going. So you can see now, this is Saturday evening, now Saturday night. Now we're getting into the cold air advection with the flow around the cyclone, bringing in cold air from Canada. If we keep going, we'll just go to 0Z on Monday. You can see then that all rotates in. We're in cooler air, and another high pressure develops on the backside of this low. And we are cooled down again. And then you can see generally across the United States, as shown, not a lot going on aside from this cyclone and then the stuff in the Gulf, which is just remaining there. It's not really moving. It's really tied to the Gulf and how warm and moist it is down there. That's all I had. Is there any questions, comments, anything anybody wants to see that I didn't point out? Yeah?
I just had a question on why would that low system move colder after the Rocky Mountain?
Good question. Let's go to just back to where it's like near the Rocky Mountains. Okay, perfect. Let's step forward like 2 or 3 clicks. So there's 2 arguments that could work. First, if you follow the thermal wind in the immediate of the cyclone has a polar component. So that would be one reasoning from Sutcliffe 1913-9. The other one would be you conserve shallow water PV, so going on the downstream side of a mountain, you're going to increase your height. You would need to increase both relative and planetary vorticity. The only way to increase planetary vorticity is to go northward. So both of those are at play. It's not a dramatic, like this cyclone is not going straight northward, but there is subtle where it's developing, it goes to the south and then it begins to move northward. Yeah, good question. Anything else? Yeah.
Well, I guess another question I just had about just like the lack of precipitation and also where the jet streams currently are. Like, and this is probably partly climate change induced, but I'm just wondering why it's taking so long to move south, like the jet stream, and why like there's no precip. Why is it so boring? I guess.
Good question. There's both components. So there's climate change. There's also the tropics can greatly influence the jet stream position. Same with like MJO, and so all of those things. Just from what I've shown, a lot of the baroclinicity is to our north. And so you set up baroclinicity, that's where your jet stream is going to be based on thermal wind arguments. So if you don't have cold air coming southward, you're just going to have your jet stream set up where the baroclinicity is highest. And it seems like it's been so warm. We had our record warmest winter. And then this summer wasn't particularly warm over us, but much of the western portion of the United States it was warm. And so you continue to build warm air, and your poles are continuing to warm up even faster. So you can imagine the jet stream 30 years ago would have sat up maybe mid-CONUS. Now it's beginning to shift higher and higher latitudes, and the jet stream is going to control where these systems move, where all the wave activity is. So you continue to warm the CONUS, your jet stream is going to shift just north. And we're seeing, just this doesn't move really at all. And so this is a big barrier for systems if they want to move over the western Rockies and then into our region. All of our stuff, as has been happening, has been coming way north of where this heat dome has been sitting and will continue to sit. Yeah, good question.
Is this tropical storm that in multiple runs? I just noticed it.
Oh, that's right.
I don't know if that's a one-off, if it's like a GFS fiction thing or what.
Yeah.
The Hurricane Prediction Center has a 50% chance of a cyclone developing in the next 7 days.
That's not good. So that's something to watch as well. That might be one of the reasons there's a bullseye of precipitation near Florida too. But at least from this run, it doesn't look like this is another hurricane. This one looks very weak comparatively, but
It comes and goes.
yeah. Doesn't matter, it can still have really strong impacts, even if it's weak. Anything else? Yeah?
Is that like wall of, when we were looking at QPF, and there was like that wall along the coast of the Gulf, is that a pretty common feature? Like not having to go inland?
I'm not sure. From the looks of it, it's just because there's nothing synoptically going on in much of the CONUS, your moisture is just going to be tied to where the Gulf is really warm and moist. So areas around it are going to get precip. You're not really moving this moisture anywhere, so there's not going to be any rain anywhere else, really. I am not sure if this is common. It's just synoptically, the next 7 days, you're under general high pressure. You can see, aside from the whatever system this is, but You're not moving any of this moisture from where. And it looks like that system does develop. I didn't even look at this, but quickly move away, which might be good. Anything else? Any other questions? Perfect. Well, we'll see you next week. Thank you for coming. Enjoy your weekend.
There's the shadow. Really close. The hard to cut off is the part I wonder if there's actually this wasn't a weird thing. Yeah, same. No, I was going to say the other thing that's northeast. You can see water value was really good yesterday too. Pennsylvania, all the Finger Lakes and the Arctic. Wow.
So ready for some of this.
I
I've been missing texts from you.
just
Like over the like. Yeah, because there's like.